This is the third video for chapter 13.1 for business calculus. This is about differential equations and an equation that involves the derivative or differentials of an unknown function. And the solution of a differential equation is any function that satisfies the differential equation. So it's kind of like what we have been talking about. So that's like one of the topics for differential equations. And then the initial value problem is one of which we are required to find the function that satisfies a differential equations, one or more initial conditions. So you may have some homework question or exam question like that. They give you the first derivative and they ask you to find the functions, but it has to fit this condition. So these conditions say when you have your f of x equal to y, your original function, they want the x equal to 1 and your y value equal to 9. Alright, so using the slope they give you, they want you to find the functions and they want you to find a function that fit this condition. So let's try that. So I'm going to say my function should equal to using the integral and put in the first derivative, right? Point of x dx. Alright, so I am taking integral of this whole derivative. So we got 3x squared minus 4x plus 8 dx. Alright, so let's do each term individually. We are going to have taking the integral of 3, but we can pull out the 3, right? Take integral of x squared dx minus, I can pull the 4 out, take integral of x dx, and then adding 8, take integral of 8 dx. Alright, so let's see what happened with them. First one, we got a 3, but then over here we should have 1 over 2 plus 1 is 3, and then x also weighs to 2 plus a 1, right, equal to 3. And then minus my 4, the x will become 1 over, this is 1 plus 1 is 2, which means that x also need to weigh to 2. When you take an integral of a number, it's not 0, okay? It's the opposite of that process. So now you need to stick an x back and don't forget your c. Alright, so that would give me just x cubed minus 4 divided by 2. Like this is 3 divided by 3, right? So this is 4 divided by 2 is 2x squared plus then 8x as c, right? So I need to know what c is. And it's supposed to fit when x equal to 1, y equal to 9. So to solve for c, what we need to do is plug in x equal to 1 and y equal to 9, right? So those number is given from the questions. So let's over here we can have my y is 9, right? And then equal to something q minus 2 times something square plus 8 times something plus my c. And we are solving for c, right? So we got 1 here and 1 and 1. So 9 equal to 1 minus 2 plus 8 plus a c. On the left hand side we're going to have 9. On the right hand side we have 7 plus c. So subtract 7 both sides. c equal to 2, right? So for this particular question, so I'm so sorry I went out of the room. Where can I do it? So for number 9, my function equal to x cubed minus 2x squared plus an 8x plus my c is 2, right? So this is the answer for number 9. Sorry about the arrangement. So that's how it works. So you take integral and you solve for c and plug it back to the function. So that's what you will have for the final answer. So hopefully that makes sense. We have number 63. 63, I changed the question, so if you don't mind, could you change that for me also? I want to change the point to 2 and 3, and then the function after taking the derivative is 4x minus 3. So I try to match this question with one of your homework questions. That's why we got that. You may need your own paper to do number 63. So let's look at number 63. Found the equation of the curve that is passes through these points and given your f prime of x, right? So very similar to the question we just did. So I can write down for number 63, it's given to us that dy dx of equal to 4x minus 3. And then it's supposed to pass the point which is 2 and 3. Alright, so we hopefully know dy dx is the same as slope, is the same as f prime of x. Alright, so what we need to do is we need to take integral of that function. So we need integral of dy dx. So this will equal to the integral of 4x minus 3. Don't forget your dx. So then we can do the functions equal to, this is going to be 4 times, that would be 1/2 x raised to second power minus a 3. Now we stick the x back and then add a c, right? So when we clean it up, 4 divided by 2 is 2, x squared minus 3x plus c is the functions. But then we need to find what c is, right? So, and then solve for c. So plug in x equal to 2, y equal to 3, and solve for c, right? Alright, so let's try it. So we got 3 on this side equal to 2 times something squared minus 3 times something plus c. So 3 is y and x is 2. So 3 equal to 2 times 4 is 8 minus 6 plus c. 3 equal to 2 plus c. Subtract 2 both sides. So c equal to 1. Are we done? Not quite yet. So the function we want is going to be y equal to 2x squared minus 3x plus c, right? So this time it's plus 1. So that would be your function, okay? So that's number 63 that we changed the questions. We have one more, so almost done. The last questions is about cost function. So if you need to pause the video and write down, feel free to do it. Very last question. Number 81 say cost functions. The marginal average cost function producing X sport watches is given by this. So they want the cost function, but they give you the derivative of the average cost. So we have to be careful with that. And then they also give you a condition, which is for the average cost. C of bar C of X is the average cost in dollars. So this is in dollars. Found the average cost function and the cost function. What are the fixed costs? Okay, the fixed cost is going to be the C, right? So let's look at this together. Let's write down what we know also. Okay, so let's see. Let me put the question up here. We want to know cost function. We were given average cost taking the derivative. We're given this. This is in dollars. I want to find the average cost function and the cost function and the fixed cost, which would be C, right? Okay. Let's see. That's asking a lot of questions, right? Okay, number 81. We got bar C pi of x equal to negative 1000 over x squared. And then using that, we can probably find average cost functions by doing what? Taking the integral of that, right? So take integral both sides. This is bar C pi of x. This is negative 1000. Can I write that as x raised to negative 2 dx? So they're the same thing, right? Alright, so integral and the derivative cancel each other, so this turn into the average cost functions will equal to, I can put a negative 1000 out. I still need to take integral of x raised to negative 2 dx, right? So that would equal to negative 1000 times, this is 1 over negative 2 plus 1, x raised to negative 2 plus 1 plus a c here, right? Alright, so let's see. So the average cost function would be negative 1000 times, basically this is a negative 1, and then x raised to negative 1 also, right? Plus a c. So I can conclude that my average cost functions is bar C of x equal to, this will negative times negative will become positive 1000. My x raised to negative 1 go to the bottom, and then add a c, right? So I got one of the answer. This is for the average cost functions. Remember when we do, let me see. So let's solve for C first. So if we want to solve for C, and then we were given bar C of 100 equal to 25, right? So it means x equal to 100 and my y value equal to 25. Okay. Let's plug it in. We got y is 25 equal to 1000 over 100 plus the c. So that will give me 25 equal to 10 plus c. Subtract 10 both sides. So that would be 15 equal to c. So we found out what is the constant, right? Okay, so let's see. This is the constant, but this is for the average cost. So we have to hold on to that. But then we can use the average cost function. So finally, we figure out the average cost functions. Because earlier we have a c there, right? So that's not the final answer. That's the final answer. Bar c of x equal to 1000 over x plus 15. So that's your average cost functions. And how do we go from the average cost function back to the cost function? So we are going to try to go from bar c of x equal to, normally it's the cost function divided by x, right? I need to get c of the x. So we need to solve for c of the x. So basically both sides multiply by x, right? So that seems to be the way we can do it. So we're going to try to find cost functions using the average cost function. So we started with this. Bar C of x equal to 1,000 over x plus 15. And then if both sides multiply by x both sides, you have x here, you have x here, then this will got cancelled, right? So then you have x bar of c x equal to c of the x. So basically, in order to find the cost function from the average cost function, you need to multiply x both sides. So x times bar c of x will equal to x times 1,000 over x plus 15. So this will turn into the cost functions, and this will turn into x need to multiply both terms, right? The first term is just 1,000, the second term with 15x. So that would be my cost functions. This is the answer. And the last part is they want to find the fixed cost. So let me get a piece of paper. So the fixed cost, using my cost functions, remember, okay, now we need to find the fixed cost. We have c of x equal to cost function equal to fixed cost. I need to plus the variable cost, right? And then we have c of x equal to 1,000 plus 15x. So 1,000 here would be my fixed cost. So, or you can think of like if you produce zero units, what is the cost for that? Then c of 0 equal to 1,000 plus 15 times 0, right? So the fixed cost is $1,000. So either way, you should conclude this same answer. So this one is a little bit lengthy because we started with the average cost, marginal average cost, not marginal cost function. So you have to go through a few steps to get back to the cost functions and then use the cost function to find the fixed cost. So it's not just the constant part. So sorry about that. Okay, if you have questions, please let me know.